Tonight, I have the privilege of introducing two special guest speakers, co-authors of a new book called Megalodons, Mermaids, and Climate Change. Dr. Ellen Prager, the chief scientist at Storm Center Communications, is a prominent marine scientist and author. She's published multiple public-friendly science books and has appeared on The Today Show, NBC News, Good Morning America, CNN, Fox News, the Discovery Channel, and the Weather Channel. She previously served as chief scientist for the Aquarius Reef Base, that's an underwater laboratory. She was assistant dean at the University of Miami's Rosenstiel School of Marine and Atmospheric Sciences, and she was a consultant for the Disney movie Moana. Woohoo! Woohoo to Moana, right? Dave Jones is the CEO and founder of Storm Center Communications. He spent a decade as an on-air meteorologist for NBC4 in Washington, D.C. Anybody from the D.C. metro area? Maybe you saw, there you go, maybe you saw Dave on TV. He now hosts summits for broadcast meteorologists, leads an award-winning science-based production team, and has tens of thousands of followers on his YouTube channel. Tonight, Ellen and Dave will be combating misinformation as they answer some of our most pressing questions about the ocean, the atmosphere, weather, and climate change. Help me welcome to the stage Dr. Ellen Prager and Dave Jones.
Thank you. Thanks, everybody. We are so excited to be here. When Zach got in touch with me and asked if we'd come back, for me to come back, I was so excited because last time I was here, I don't know if anybody was here when I did a talk about sex, drugs, and sea slime.
Yeah, you remember that.
Well, I just remember the audience being so good and engaged, asking great questions. So it's a pleasure for us to be back. And now I get to bring Dave with me, and so you get a 2-for-1 deal. So Zach already told you a little bit about us, but we always like to show some photos to go with that because we've our jobs are sort of adventures, but Zach sort of mentioned some of the things I've been fortunate enough to do, from living underwater in an undersea research station for 1 to 2 weeks, taught oceanography aboard a tall sailing ship. Yes, probably for most people, my most famous job is a consultant for Moana. And when things happen...
That's her on the ship. Actually, the boat right there.
When things happen in the news, I get calls from CNN or the Weather Channel and go on air to talk about the ocean, or it could be earthquakes or tsunamis. And kind of a surprise even to myself, I discovered a new love, and that is writing books. And some are for kids, young kids. Some I actually have some middle grade series, some adventure series, and popular science. So it was a surprise to me, but it's kind of got in my blood now. And in fact, before this book, I wrote a popular science book, and I said, Dave, if I say to you, I want to write another popular science, I said, smack me across the head. 2 weeks later, I have a really good idea for a book. So then, a little bit more about Dave.
Yeah, so I'm Dave. Hi, and I had a lot of fun. I got my start at NASA Goddard Space Flight Center in Greenbelt, Maryland, where I was supporting a research meteorologist, and then I got to do the weather on Channel 4 for about 10 years, and that included 3 or 4 stints up in New York to do the Today Show. And that was a lot of fun as well. Just a quick little story about that. I was working locally at Channel 4, and Willard Scott, how many remember Willard Scott? A lot of people. Willard's a great guy. So his office was downstairs from where Channel 4 is located. He was with the network, and they asked me to do the Today Show. So I went down and I knocked on Willard's door. He was like, Dave, come on in. And so I said, Willard, they asked me to do the Today Show. I said, you got any advice? And he says, yeah, don't listen to a damn word they say. That's what he said. So that was a lot of fun. And then we got to do some talks around the country on sea level rise. And then that picture, the second one from the left, on the lower left, I've done some work in emergency operations centers at states that are looking to use new types of data and how they can use data more. So it's a lot of fun there.
So we decided to get together and combine meteorology and oceanography, we have the world covered now, to write a book together. And one of the things that happens is ourselves and our colleagues, we get asked a lot of questions, and we love questions. And so we thought, wouldn't this be a great thing to do for educators, for students, for general public people like yourself, to give good, easy to understand data and science-based answers to those frequently asked questions, plus have some fun with some of the more zany questions that we and our colleagues get. So these are, we're going to show you some of our favorite questions and answers, and they're not just from us, they're from other leaders in the field. Some of our colleagues, we queried them, and we just thought it would be a fun book altogether. And you'll see we hired a graphic illustrator to have a little fun with us. I want to say thank you to the Alfred P. Sloan Foundation and to NASA Heliophysics, because it was great. They both gave us grants to help do research and write the book, so that is very appreciative. So, inquiring minds want to know about things like ocean temperature and sharks and climate change and, of course, algal blooms, living where you do. But there's a lot of misinformation out there. For instance, you might have seen this picture after a hurricane online or somewhere, and gosh, it looks like there's a shark on the highway.
Looks like that to me.
Oh look, here's New Jersey. Boy, that shark is really getting around. That's from Sandy.
Yeah.
Oh look, it made its way all the way around the country to California.
Those highways look exactly the same, don't they?
And in fact, it's the same shark even in a subway system.
In Toronto, Canada. Boy.
So, and you know, you see these pictures come up, and people are like, is that real? And then you start, if you go actually and look at it, it's all the same picture. No, it is not real. How about this one, Dave?
Well, in the 1970s, scientists really did say an ice age was coming.
There's
Yes.
a kind of a myth out there.
There's a myth out there. So here is what it looks like on the cover of Time magazine, because somebody got a hold of that magazine and altered it and sent out something about how the global warming survival guide. Right? So
that's what
the
the
real one is on the left, Global Warming Survival Guide, and somebody changed it to How to Survive the Coming Ice Age, which was not real, and guess which one got a lot of exposure?
The fake one.
The fake one.
We
on the
still
right.
have people when we say, well, didn't scientists say in the 1970s we were an ice age? Because I saw it on Time, and we're like,
Yeah.
no.
Right.
Questions. We love questions. And I can tell you a little story about Dave. We don't plan this ahead of time necessarily, so he doesn't actually know I'm going to tell this story. But at a big meteorology conference, Dave asked so many questions. At the break, at the intermission, one of the organizers came up to him with a microphone and said, Dave, why don't we just give you a mic? Because we know he's going to ask so many questions. But the best thing was, later that day, a young meteorologist got up, walked up to the mic, and was very shy and said, I usually don't really get up and ask questions because I'm nervous, but Dave inspired me. So questions, and this is our sort of dedication for the book, are the lifeblood of learning. And so we hope at the end we're going to leave plenty of time for questions because we think it's so important that people do that. So, one of the questions that comes out a lot is, which is more important, the ocean or the atmosphere? I think it's pretty clear by who is winning the arm wrestle. It's the ocean.
Yeah, well, let me just say something about this. Because the sketch artist that we had, she's very talented. But first of all, I don't know why I'm sweating, first of all. And secondly, I said to her, Elise, could you please give me some muscles? I mean, well.
Well, and then the other thing is we were at a meeting, the same meeting we were giving a talk, and somebody said, Dave, do you have dentures? And so I said,
No, that's my mustache. That's not dentures. Good grief.
So we'll come back to this question later. So first of all, some of the questions that I and my colleagues get in the oceans, and particularly from kids, and it's a really good question. They say, are there any new species out there left to discover? And the answer is absolutely yes. In fact, almost every time scientists go out to a remote place in the ocean or a place that we've been to but haven't studied very well, we find new species. They're not giant charismatic like dolphin species. A lot of them are smaller, but here are a couple of really cool-looking animals that have been recently discovered in the deep ocean. One is a comb jelly that looks up. That's in the upper left. Kind of looks like an undersea hot air balloon. Casper, they called it. That little octopus on the bottom there was Time's Creature of the Year one year, and it's pretty recent. And I love this glass sponge on the right that was found deep in the ocean. It almost looked like an alien, and they sort of named it the magnificent alien in Latin. So yes, you were wondering about the Megalodons thing. So I was giving a talk, and this young boy, really, really smart guy says, I had just said, oh, we've only explored something like 5% of the ocean. And I said, Megalodons are extinct. And he said, how do you know they're extinct? You just told me you've only explored 10% of the ocean. How do you know they're not down there? So, and this was the top question of my ocean colleagues of what they get asked, was Megalodons. Do Megalodons still exist in the ocean? No, they're extinct. They were the biggest shark ever millions of years ago, but we know they're not roaming out there unseen. And look at that cool comparison of the megalodon tooth versus a great white, makes it look kind of dainty. But here's how we know. The only megalodon tooth, let me preface this by saying, sharks throughout their lifetime, they create and drop about 40,000 teeth. So think about this. If there were giant megalodons roaming around the seas today, they would be dropping 40,000 teeth a year. We would find a lot more, and they would be modern. The only teeth we find from megalodons now are black or fossilized. They're millions of years old. There are no bones of modern prey that have evidence that there are megalodons were feeding on them. And we know from where we find teeth, the fossilized ones, that they fed in coastal waters. And if you think about it, that makes sense because they had to eat a lot of food, and the coastal waters are the most productive. And so finally, yeah, there's no video, there's no photos, there are no real sightings. Gonzo. They do not exist anymore, but they did millions of years ago.
And movies don't count.
Yeah. Or Facebook, or TikTok. That is not scientific data. So we have another chapter about dangerous marine life, because sharks, everybody asks questions about sharks. Of course, what are the chances of being bitten? And they are, 1 in millions, very low chance of being bitten. In fact, you are more likely to be fatally wounded by a toaster, to die from taking a selfie, or lightning, which we will get to later. And besides, people taste terrible, and we're full of additives. One question we get is about sharks is, can they see color? And because of their eye structure, the answer is no, but they can see contrast. So I don't know if you have ever heard the idea of something being yum, yum, yellow, because sharks can see yellow. They can't see yellow, but they can see the contrast between something bright like yellow and maybe the dark ocean behind it. But they can't see color. And finally, this one, you hear this a lot, right? That if you cut yourself and you're dripping blood in the ocean, a shark is a mile away, can smell it. Actually, I talked to some shark experts who study sharks all their lives, and they said that is not true. They said the best a shark can do in detecting chemicals or blood, what we think of as smell in the ocean, is a small pool. If there was a drop of blood or a teaspoon of blood in a small pool, they might be able to detect that. But think about in the open ocean with currents and turbulence and waves, the whole mile away, nope, don't worry about that. Jellyfish. So This is one of our favorites.
They're so beautiful.
They're so beautiful. But if you get stung by a jellyfish, should you or your friend pee on it? Now, this has been an old wise myth for a very long time, made even more famous when it was on an episode of Friends. Well, the answer to this is no. Absolutely not. Because in fact, if you pee on it, one of the things that triggers the sting on a jellyfish is a change in the chemistry in the water around the jellyfish. Your urine does not have the same pH as seawater. So not only will it not help, it could make it worse, could trigger the stinging cells. So no, do not do it.
Oh, wait, these sketches, right? I mean, I have just one thing to say about, so I said to Elise, okay, no muscles, that's fine. Now, could I at least have a little bit more hair, right? I had a lot of hair 10 years ago, maybe 20.
So this is what she did. She said, there you go, Dave.
I got my own ponytail. That's all.
So we just added this afternoon, this picture, because we were out on the beach here in Stewart, and we saw Portuguese man of war, and there was a family, and we said to them, because there was little kids running around, and we said, please, make sure you don't touch these. And the mother said, why? It's pretty. So Portuguese man of war, they're not jellyfish. There's something called a siphonophore. They're closely related. But those blue tentacles are packed with very strong stinging cells, and I can personally attest to that.
Not today.
But not today,
yeah.
But yeah. And even on the beach, when the Portuguese man of war are on the beach, and you might think it's dead, the stinging cells will still fire. So if you're on the beach, or if you see them in the water, don't go in the water. And if they're on the beach, please stay away from them and make sure if you see any kids around them and pets, do not let dogs get near them.
And today, this picture on the right-hand side, you see that footprint? That person was vaporized. I mean...
This is why he's a meteorologist.
I mean, it's clear as day right there.
So what should you do? If you get stung by a jellyfish, and in fact, a lot of lifeguard stands now have vinegar. You want to rinse it with vinegar to deactivate or turn off any stinging cells. We're trying to remove the tentacles from your skin, and then actually apply heat, which will deactivate the venom. So that's what you should do. I think this is one more topic. We have quite a few more topics about the ocean in the book, but I wanted to touch on coral reefs because they've been in the news a lot lately. Climate change is kind of plays like whack-a-mole with coral reefs. It's not just the rise in seawater temperature, it's also that the ocean is becoming more acidic, the sea level is rising very fast, and what's happening is we are decimating coral reefs throughout the world. We go into a lot more detail in the book about how climate change impacts coral reefs. And so it's just a huge issue. It's a real problem across the world. But also there are a lot of efforts globally to now intervene to try and save corals, what we call coral restoration. I'm not going to tell you that's the answer, because it's not. Unless we do something about climate change, you can grow as many corals as you want in a nursery, but as soon as you put them back out in the ocean, they're going to die like the natural corals. And so we need all sorts of actions. We need marine protected areas. We need to reduce overfishing and pollution, all those things to make corals less stressed. But until we do something about climate change, they're going to stay in trouble. I'm not against coral restoration. I think there are some really good programs that are trying to put corals in the lab and look at heat-resistant corals. So I think there are plenty of things we should do, but it's not a Band-Aid. It's not going to fix the problem. And I talk a lot about that in the book. Weather. Let me turn it over to Dave for a little bit, because I know where we come from, we live in Annapolis, Maryland, it's snowing right now. And one of the big questions people always want to know is, how much snow is there going to be? And that's not an easy answer. But Dave?
Not only that, how much am I going to get at my house? At my house. That's what everybody wants to know. Ellen's name is first in the book, so she gets to talk about oceans first and all that stuff. I talk about weather here. So, when I did the weather on Channel 4 in Washington, I would get calls all the time. One of the calls that I got from a nice lady was she said, Dave, we watch you all the time. You guys, Bob Ryan, Tom Curine, you're the most accurate. You're never wrong. We were like, oh, well, thank you very much. That's appreciated. What's your question? And this was like January. She said, my daughter's getting married on July 17th. Could you tell me if I need a canopy or not for the wedding? And I said, could you hold, please? And I put on, who gave me this call? So indeed, people want to know what the weather's going to be like way far in advance. And so, first of all, many people, you can see on that cartoon on the left, we got that at the airport, flying down here. Said hi to a gentleman sitting next to me, and he heard me say I was a meteorologist, and he said, oh, you get paid for being right 50% of the time, don't you? You know, that's what he said. I said, well, you know, we're a little bit better than that. But, and then long-term forecasts. Long-term forecasts, if you hear anybody saying they know what the weather's going to be 15 days from now, 30 days from now, 45 days from now, or you have a weather app that you can look at and look at that forecast, don't believe it. It's going to change, and we're pretty accurate now out to about 7 days. The forecast today at 7 days is about as accurate as the 3-day forecast was about 10 years ago. So it's improving, but the 15 and 45 days aren't there. We call the 30-day forecast Fantasyland. That's a sketch from the book. Oh, I need to. Are you going to do it? Okay. Okay, so how many like clouds? How many of you go out and just look up at the sky and see clouds? Yeah, it's a free show, doesn't cost anything, and you can get lost in what's going on because some clouds move one way while higher up they move a different way, all because the atmosphere behaves in layers. And these clouds, I love clouds too, so I think I have more clouds than pictures of clouds than my kids, but don't tell them that. These are lenticular clouds. People see them and think that they're UFOs and even report them as UFOs. But no, they're really awesome clouds. And the next picture shows this one above from the Mount Shasta Museum. You can even have many layers of clouds. Yeah, and so lenticular clouds, you need a mountain or some kind of obstacle to create the pattern in the atmosphere where you need these clouds to form. You definitely need strong winds. I was flying into Steamboat Springs, Colorado one year. I looked down, all the way down to Boulder. There was a 300-mile long lenticular cloud. And I said, uh-oh, that's going to be a problem. 2 minutes later, our plane went down 10,000 feet in 1 minute because we were caught in a rotor vortex. And then he gunned the engines, and we went up 10,000 feet in a minute. So these clouds are really, they're really turbulent. You need moist air too. And look at these. These are really spectacular. When you put them into motion, look at that. They just sit there, look like they're rotating somewhat, and look, they're staying there, and there's a roll cloud underneath, all because of different layers in the atmosphere. The winds are doing different things. And if you look at clouds and just watch them over a period of time, and look at that, they're just not moving. They're moving and rotating a little bit, but they're not progressing across the land. Just really spectacular clouds. It's just amazing. Wow, look at these. These are clouds. Don't you go out, if you go outside and you see that, you say, well, look at those Kelvin Helmholtzes. Woo! That's pretty awesome. These are like breaking waves in the atmosphere. And the atmosphere is just that. We treat it as a liquid. That's why we had to take a lot of thermodynamics and atmospheric dynamics, fluid dynamics, going through college. And on the right-hand side, look, there's still Kelvin Helmholtz waves, but they're further spread out. The wavelength is longer than the short wavelength here on the left-hand side. Really awesome. Oh, what about contrails? Look at this. Yes, they're made by man. Contrails are made by man, and look at that. Some of them you see in the upper right-hand picture, you see that some contrails stop, and then they start again, and then they stop, only because the airplane flew through dry air, and the exhaust from the airplane didn't condense and make clouds, but then when it hit moist air, it condensed. So this is what we see a lot of too. How many of you have heard the word chemtrails? Couple of you. I see a couple hands out there. Some people think it's mind control, chemtrails, and I'd say, oh, brother, it's condensation from an airplane. This is exactly how a contrail forms. When you have hot, moist air coming out of the back of a jet engine in high humidity areas where you have clouds can form in high humidity areas at different levels of the atmosphere, the vapor freezes and forms tiny ice crystals, and then those crystals form in the wake of the plane to make a contrail. And you can see as they're flying along, that's what you see in the skies. And they make for beautiful sunsets, but research is showing that contrails do reflect large amounts of the Earth's heat that adds to global warming, adds to climate change, because it's almost like you're putting a blanket in that small area of the atmosphere. You're putting a blanket over the atmosphere, and it's reflecting some of the heat. It's really amazing. Lightning, not lightening, lightning.
Some of us have pet peeves.
Yes.
When Dave sees lightening, he had more hair.
I had my, I pull it out. I have one bang, though, left. But look at this. This photo on the left-hand side of lightning, this is a cloud-to-ground lightning strike that hits the ground 10 to 15 miles away from the parent thunderstorm. So there's a saying out there, when thunder roars, go indoors. And I want to do something with you real quick. Close your eyes just for a second. Keep your eyes closed. And whenever you hear this, that's a distant thunderstorm. And I have it right here. When you hear thunder outside, you should go indoors, because lightning can strike out of the clear blue sky. Where this lightning bolt struck, if you look straight up, you see the stars.
Now, Dave, one of the questions that I got, and in fact something I was told, was that if you're out and you see, and this is very common in Florida, off in the distance, you see lightning in the distance. You see flashes across the sky, but you don't hear thunder. I was always told that was heat lightning, right? Has people heard that before? It was heat lightning?
Heat lightning, of course, it's everywhere, right? No. It's not heat lightning. It's lightning that happens from a thunderstorm, but the air is too humid and it absorbs the sound of the thunder, so you can't hear it.
Or you're too far away.
You're too far away. The thunder can't make it because it gets absorbed by the atmosphere and that moisture. So you just see the flash of the lightning. Lightning travels a lot faster than sound, so you never hear that sound. So heat does not cause lightning. Thunderstorms cause lightning, and there is thunder, you just don't hear it. I'm sorry to disappoint you if you thought for 50, 60, 70 years it was heat lightning. Ellen's email is So, will trees protect us? How many of you think trees will protect you from lightning?
Thank you.
Thank you. Absolutely not. Lightning likes to strike some of the tallest objects. Often trees are those objects. And when the lightning strikes the tree, the energy from the lightning spreads out along the root system. So if you're anywhere near a tree, you can get electrocuted from a lightning strike if it hits a tree. And even when there's no storm overhead, you can get struck by lightning. Now, this is Ellen.
I was having a bad hair day, what can I say?
So regularly check the radar. If you think there are thunderstorms around, you really don't want to hop in the shower.
Or
Dry your hair. Or use an electrical appliance. Because if lightning strikes in or near the house, current could come through the electrical system into the device that you're holding. A lot of houses are grounded and they have grounding lines into the ground, but if the lightning strikes the house itself, it could come through those electrical appliances. Thank you, Ellen, for posing for that. It took her a while. It's pretty funny watching the artist do that. Hurricanes. We've had enough of those hurricanes here in Florida, that's for sure. Hurricanes are really powerful, powerful systems. This one at the top is an incredible satellite image. I say incredible. Hurricane Ian, one of the most destructive storms in Fort Myers history, and southwestern Florida. This was a Landsat image showing the multiple vortexes and turbulence in the eye, the satellite image. That satellite passes over once every 16 days in a polar orbit from pole to pole as the Earth rotates. It gets to paint the Earth with imagery. And it came over when Ian was just off the coast. That's exactly the same time where a NOAA Hurricane Hunter aircraft was flying through the eye wall of Ian and had extreme turbulence. Extreme turbulence. They really don't typically feel that. They felt it in Hurricane Hugo in 1989 as well. But they were very fortunate to get out of there, and they released a UAV, little aircraft that was going through the eye wall, 206-mile-an-hour winds they found there, and that's one of the Guinness Book of World Records. That's what the eye looks like when you're flying through it from an airplane, from the Hurricane Hunters. That's called the stadium effect. If you're in the eye of a hurricane, you look around, it's like you're in a big stadium. That eye wall is 10 miles high. 10 miles. And if you go right into those clouds there, that's where you hit the maximum winds of a hurricane. So, questions we get, so we can maybe lower the number of hurricanes that we get per year. How about we just tow an iceberg to the Gulf of Mexico? What do you think?
Lower the temperature
that'll
of the ocean. No.
No, won't work. How can you tow an iceberg from the Arctic all the way down? You'll have an ice cube by the time you're there. What about we create an oil spill to stop the evaporation that feeds the hurricane development? Is that a good idea? No. Nobody likes tar balls, that's for sure. Why don't we just nuke them? We see one forming, all gone, right? Well, not only will it not disturb the circulation of a hurricane because it's so large, but you've just caused a couple of other problems with fallout from a nuclear weapon. What about the cone of uncertainty? The cone of uncertainty is something that the public has a real tough time understanding. How many of you feel really comfortable with that cone of uncertainty when you see it?
The forecast cone.
The forecast cone. You understand it? You know what it means? Yeah, some of you do, and that's great. The cone of uncertainty is not a cone of expected damage. The cone of uncertainty only depicts where the National Hurricane Center forecasts the center of the eye to move. And hurricanes have a lot of destruction hundreds of miles away from the eye. Okay? So, and that only is accurate 66% of the time. So 33% of the time, the hurricane can move outside of that cone, and that is expected from the National Hurricane Center. Okay?
So I have family that lives in Florida, and then somebody said to me, I'm not really too concerned about this hurricane because we live near some old Indian burial mounds. The old Indian burial mound theory that they will deflect hurricanes. So just me telling them based on science, I don't think that's going to work. I decided a picture would be much better. So here is hurricane tracks going back to the 1840s, and all the blue dots that you see are Indian burial mounds.
Uh-oh!
They do not deflect hurricanes. In fact, the number is something like approximately 484 sites are within less than a mile of a storm track. And the storm tracks are depicted as thin lines, which we know they are not. So if you ever hear friends or family say, the Indian mounds will protect them, say, where's your closest shelter? Get your, hurricane shutters up. No.
And if you can always say, okay, show me the data.
Show me the data.
Show me the data where you have not been hit by a hurricane. And then, of course, all of you will funnel past the table to pick up the book. There's a picture in there, and it's this one. And you could say, I have the data. And remember, each one of these lines, as Ellen said, a hurricane is roughly at least 300 miles wide, many times 400, 500, and 600 miles wide. So you can see no one has escaped the path of the storm.
Climate change. So we have a chapter devoted to climate change. We don't have time to go into all of it now and all of the questions. We really tried to take the most frequently asked questions about climate change because it's very important. We want people to understand what's happening. One of the most common ones is, hasn't the climate always changed? And the answer is yes. The climate change has changed for millions and millions of years, hundreds of millions of years. But the issue now is the pace of change is faster. It's been accelerated by human impacts. And there's clear data to show this. It's accelerated. And the causes of climate change are different than they were in the past. In the past, there were things about the orbital cycles, about the Earth, about the sun, and the Earth spinning on its axis. Those were driving factors. But unquestionably now, the data shows the driving factor is carbon dioxide in the atmosphere. And one of the things, actually somebody asked us pretty recently, they said, yes, but there's not very much carbon dioxide. It's a trace element in the atmosphere. How could it have that big of an impact?
There's no way.
Well, think about this. Everybody's heard about fentanyl, and if you just get a tiny bit of fentanyl, you can die. Arsenic, just a tiny bit, you can die. It doesn't have to be a big amount to be potent. For certain substances, small amounts can have a big impact. They're very potent. And that's what happens with CO2 in the atmosphere. It absorbs the heat coming off the Earth, and like Dave said earlier, like a blanket. And the more CO2 we put in the atmosphere, the more blankets we're putting on, and we're accelerating the heating of the climate. How about the sun, Dave? That's another one. It must be the sun.
Yeah, many people say it must be the sun because the sun is so much larger than the Earth, and it has so much energy. And we go outside and we get sunburn after 15 or 20 minutes. Me, 5. And so look at this graph on the left-hand side. Temperature versus solar activity. And so the solar activity, whoops, what did I do? Where's the laser? Right there.
No, it's that one, yeah.
That one?
Yeah.
Oh, yeah. Okay, sorry. So solar activity, look at this, is the yellow line. And we can see ups and downs in the solar activity. And here we are now. The activity on the sun is actually going down. This is 2020. But look at the global temperatures.
If we didn't have the impacts of CO2 in the atmosphere, we actually should be in a cooling phase.
That's right.
How about volcanoes?
Certainly volcanoes are happening all over the place.
They put CO2 in the atmosphere, they
Water
put
vapor.
water vapor, and there was just that, you guys have probably heard about the Tonga eruption that was really big and put a lot of water vapor in the atmosphere. They did the calculations, and even that one, minuscule amount compared to the impacts of CO2 in the atmosphere. So no, it's not volcanoes. And one of the things that we can do is we can run models that have proven very good in replicating the atmosphere and the climate, and we can take out things or add things. And if you take out CO2, you cannot replicate what is happening today. So you could keep in volcanoes, the sun, the orbital factors. The only thing that allows these models, which have proven very accurate, that will replicate today's changing climate is when we have human impacts release of CO2. Can't we just adapt? It's happening too fast. We could adapt if we had a long time, but our infrastructure and everything a lot of the things we built have not been built for this climate. But what about, is You know, we don't like to be all doom and gloom. Is it too late to make a difference? Dave, what do you think?
No, it's not too late to make a difference. I mean, you can take steps to make a difference in your own household, that's for sure. And you can certainly do something that a lot of people sometimes don't do, and that is get more educated, like you're here tonight, understanding more about how these changes happen. And you can do something that everybody has the right to do. And what is that?
Vote.
Vote. That's right. You want to put people in office that understand that these are issues and address them responsibly.
And we're talking from school boards to your local elected officials. You can vote and you can support organizations that are doing things to help.
Yeah. So, extreme weather. This is the thing that we're seeing on and on and on, and it's getting more and more and more frequent. More intense precipitation and flooding is happening. Why? Because we're seeing more warmth in the atmosphere. And here's what happens when you have more warmth in the atmosphere. Warmer air holds more moisture. Colder air holds less moisture. So with every 1 degree Fahrenheit that the atmosphere raises in temperatures, it holds an additional 4% water vapor. So the more it gets warmer, the more it rains, it's going to rain more intensely. How many of you have noticed, even here in Florida, that rains have been happening harder, more intensely, creating localized flooding? And that's what's been happening. So wildfires are extreme. We've seen them going on in Southern California, those Santa Ana winds, 80 to 100 mile per hour winds. They had a lot of rain last spring, a lot of vegetation grew up, boom, flash drought. They didn't get much rain for the next 8 months. And that left everything looking just like kindling for fires. And when they start, they really spread rapidly under those Santa Ana wind conditions. Drought. Areas where we've seen drought, we're seeing drought longer periods of time we're seeing drought. And where we see precipitation that has been relatively normal or above normal, it's even heavier. In New England, for example, 71% more precipitation they're getting than they have 20 years ago. Heat waves. We're seeing more heat waves because drought is a feedback mechanism. But we're also seeing these high pressure systems called heat domes that establish themselves over the central part of the United States. And when that happens, it forces the jet stream up to the north in Canada and then down, over the Atlantic Ocean. And when that happens, no weather systems can really impact the central part of the U.S. And we're seeing stronger hurricanes. We're seeing many more Category 4 and 5 hurricanes. Last year and the year before, in 2023, the Atlantic Basin and the Gulf of Mexico was much higher than average. It was like 3 to 4 standard deviations above normal for the sea surface temperature.
So one thing, just to be clear, we're not saying that climate change causes hurricanes or causes drought. It's just that it makes those things more extreme. It rains harder, the hurricanes are stronger. Climate change isn't causing them to happen, it's just making them more intense.
And it's sort of like, you think of climate change as loading the dice. When you roll the dice, more often than not, an extreme event is going to happen. That's kind of what climate change does. It sort of fixes the dice. Another analogy is that weather is the punches that the boxer throws, and climate change trains the boxer.
Okay, no more analogies. Give me that thing. Oh, space.
The sun.
Space. We have to say something about space weather. You guys, anybody here have been lucky enough to see an aurora? Anybody? Oh, we're so jealous. Yeah. That is fantastic. We worked with some experts at NASA to write a chapter about the sun and about space weather. And, I have to say, I was kind of like, I'm not exactly sure what space weather is. Well, and what they explained to us very clearly is space weather, it's not from a galaxy far, far away, what's going on out there. It's strictly between the sun and the Earth, what's going on in between there with solar flares, when you have CMEs or things happening with the sun and how they impact the Earth or astronauts. So that is strictly, and so we have a chapter on the sun. We worked with NASA on it to make sure it was right. And it's been really interesting for us learning as well.
Yeah, big thing when the astronauts are up there in the space station, you have to monitor how much radiation is coming from the sun towards the Earth, because they cannot be out there doing a spacewalk if there's a coronal mass ejection and there's more radiation heading in their direction.
So we recommend, in terms of, how do you know what's right? How do you get by misinformation?
First thing, it's very essential, very important step.
Really, we say ask questions. We want you to ask questions. Don't be shy. Check the source of the information, where it's coming from. If you can, find the original study and data. We always say, we have a chapter saying, show me the data. And ask an expert, somebody who is an expert in the field. And we have another drawing in the book, I'm not going to spoil it, about what kind of expert you should be asking about certain things and what maybe not, like a veterinarian for certain things versus not. Well, that's a little teaser. But what about this question about which is more important, the ocean and the atmosphere? Well, in truth, they are a coupled system. We're engaged.
We're getting married!
And so, again, if you don't get the book this evening, you get them anywhere they're sold. We have also partnered with the Aspen Global Change Institute on projects about science communication and engaging the public, Dave's YouTube channel. But now we want to open the floor to you to see if you have any questions for us.
Thank you very much.
Thank you.
Thank you.
Oh, we got some hands up. How about?
Oh, yay. We have some questions.
We have some questions.
And as soon as the microphone runner is coming, I guess, we'll have...
Or no, I think...
No?
Okay.
Oh, we'll repeat the question.
Yeah. How about in the back in the sort of greenish? I saw your hand go up.
Yellow, yes.
So stand up and...
Green.
Thank you so much for coming to see us and on the information. I'm kind of curious if you have any mermaid stories.
Oh, mermaid
Some people
stories.
showed up for mermaids,
Mermaids.
too.
So,
Yeah, the question was...
first, I would like to preface this by saying I am not anti-mermaid. I love mermaids. I think they are wonderful. But just like megalodons are extinct, there are no real mermaids in the ocean. I'm very sorry. I'm very sorry. But I do have a funny story.
And we have a picture in the book.
Yeah, because let's just think about mermaids. In those classic depiction, they're very slender, wearing a bikini. They've got beautiful long arms. Most of the ocean is very cold. If mermaids were living in the ocean, especially in like more than half of the ocean, they would either have to be very blubbery, have a full set of like fur coat all over them like an otter, blubbery, furry, and those nice slender arms would fall and freeze and fall off. So there are no mermaids. And if there were mermaids, they would look very different. Yes.
Yes, sir.
Is there a problem with the plankton in the ocean? Are they being stressed out?
Is there a problem with plankton in the ocean? Are they being stressed out? Well, it would depend on where you are. So some of the plankton are changing because of climate change and the temperature of the water. You have different species in different places. There are problems with when you hear about dead zones and places where you get no life at all because you have, and this is kind of what happens with some of the algal blooms here, is that if you have a lot of algae and some of it starts falling to the bottom, decomposing, two things happen. Bacteria use oxygen to decompose the algae, and if you think about it, if you have a lot of algae up in the water column, it blocks light from getting through for photosynthesis. Those two things together essentially are using up oxygen, and you get low oxygen or hypoxic zones or dead zones, and then everything dies. So phytoplankton or zooplankton, it all depends on where you are and what's happening in that ecosystem. And so in some places there are problems, in some places there aren't yet. That's the best I can tell you. Sir?
Do you address the dirty part of a hurricane, like when a hurricane, when you see it come, everyone says, you know, the most hazardous part of a hurricane is the northeast, the dirty side. Can you address that?
Sure. In a hurricane, you know, it spins. Sure, yes, I'll repeat the question. Can I explain the dirty part of the hurricane and what is that about? So the dirty part of the hurricane is if you think about a hurricane moving forward, it's the right quadrant of the hurricane where you have feeder bands that are coming in and spinning off of the hurricane. That dirty part of the hurricane can produce a lot of tornadoes. And that's because the shear is there. The winds are changing direction as you go up in altitude. And so particularly when Milton came across Florida, there was an extraordinary amount of tornadoes, long track tornadoes that are pretty rare in feeder bands and outer bands of hurricanes. That came and swept right through Florida. So many of you probably know some people who are impacted by tornadoes. But that's the dirty part. If you think about the hurricane moving in a direction, it's the northeast quadrant, the right quadrant, where a lot of things could happen with regard to tornadoes. And you can't issue tornado warnings until you actually detect them on radar, and they're usually very fast movers, and many times they're rain wrapped. You can't see them, but they're right on top of you before you see it.
Yes, sir.
How come during this last election, the national media totally fumbled the ball on climate change?
So the question is, during the last election, how come the national media fumbled the ball on climate change? Well, in almost all elections we've had, the media has not made climate change a very big topic. And why that is, that's a great question. I'm not sure I can answer. I mean, part of it is because it's not so, a lot of the media, they're not experts. And, you know, so that's not something they're very familiar with. And so they don't, and they use their polls and they say, you know, people think more about the economy than climate change. So, you know, it's a really good question. I would like to ask them that question myself. Do you have any?
I do. Thank you for asking.
Oh, you're welcome.
So we do a lot of work with broadcast meteorologists around the country. We had a weather and climate summit that we would put on and invite broadcast meteorologists and scientists to come to spend a week together and get educated from scientists about what's going on. COVID killed it, so we're trying to reboot it now and get that going again. But television stations do, like Ellen said, a lot of research. And they don't like to touch really sticky things if a large part of their audience doesn't believe in climate change. And climate change really isn't a belief, it's actually more scientific fact. But they don't want to have, Thank you. They don't want to have their meteorologists spending a lot of time talking about climate change because they think half their viewers will turn the channel.
Whether that's true or not.
Yeah, whether that's true. But here's something else. Weather, for your local TV stations, weather is the #1 reason why people watch local news. To turn on their local news because of the weather. That is the driver. So there's a lot of debate and conversation going on right now between local television station management and their meteorologists that are on staff because they want to do more. They're not trained and they're not experts in climate change, but that's what we're trying to bring to them because they just don't have time. They're being asked to do social media, being asked to do radio, being asked to do more shows on the news, and that takes all their time. So they don't have that extra time, teachers to get their continuing education.
Another answer to that question is that in the past couple years, maybe the past decade, A lot of the news agencies have gotten rid of their science reporters or science journalists. And so now the people who are posing the questions and covering the stories are generalists. And it's sad for everybody that we've lost a lot of that expertise in the newsroom in general. So why? Because of cost cuts. Because they've said they're cost cutting, and they said, well, if we're going to lose something, oh, we don't really need that science reporter. Our regular reporter can cover it, which isn't necessarily true.
Yeah.
Right.
And many stations around the country are taking away the crew that goes out to do the stories. It's the reporter. They're called, multimedia journalists now, MMJs, and they have to do everything themselves. They set up on their iPhone, the tripod, they make sure they're right, they do their story, they do their stand-up, and they don't have the support crew around them, so they're really...
Did you hear about that TV channel that was doing away with their meteorologist?
Oh, yes, the question was...
Yeah.
Yeah, did we hear about the station that wants to do away with their meteorologists? Yeah, that was a particular ownership group that owns the Weather Channel. And so they were going to replace those local meteorologists with what's called hubbing from the Weather Channel to do that local weather. Well, there was a huge backlash to that because people like their local meteorologists.
Well, think about storms. Would you want somebody in a centralized location giving you very specific information for your town, your
Well, they may not
region?
even know your area.
They may not
right?
know your area, what
Yeah.
the issue, what the big issues or what the geography of your cities are.
Yeah.
Those people during emergency situations, no, nobody would want that.
You wait for Jim Cantori to come in.
Oh,
That's right.
She said she waits for Jim Cantori to come. Jim is a good friend of ours, and so we always give him everybody would love to give him a hard time.
It's a joke.
Cantori.
Right. Yes, sir.
Yeah.
What's the chance of the Gulf Stream stopping?
What is the chance of the Gulf Stream stopping? You've probably seen conflicting stories about that. A paper came out a little while ago saying it was definitely slowing, and then a new paper came out saying, no, it's not definitely slowing. One of the problems with that is that our record of data is short, and it's very variable. So you could see slowing, and then it slows down, and then it speeds back up. And we know that's happened in the past, that it's gone up and down, but we don't have a long enough record. And also think about, how do you get that data? We've been pretty recently that we've had these buoys that go up and down in the water column and can flow for days and weeks on end. That's very relatively recent. So we don't have a lot of long-term data, and getting the data is really hard. And so I think interpreting short pieces of data is very difficult. And I think what we do know that there have been periods where it slowed, and then it started back up again. And I think right now, the best answer is we know it's slowed in the past. We know there are times when it's slowing, but is it on a trend to slow right now? We don't know that.
Yes, sir.
Another question, more of an observation about your, why you guys are probably getting so excited Megalodon questions. It's probably due to the fact that Discovery Channel aired a program during Shark Week several years ago, a documentary about
Documentary.
Oh, the old mockumentary about mermaids and megalodons.
Yes.
Absolutely, and that's exactly what we talk about in the book.
It's in the book.
It's
Right
in the
over
book.
the table there
And-
before you leave.
Yeah,
It's right.
and in fact, I should say myself and my colleagues, we got so many questions after those two fake documentaries that Animal Planet Discovery did about megalodons, and they had fake scientists, and the thing was, there was very small type saying, this is not real. These scientists are actors. But you had to read it. It was like up for 2 seconds. But after that, especially kids, but also adults were like, well, it's kind of a government cover-up. We know there's megalodons and mermaids down there. Yep, you're absolutely right. And I talk all about that. Or we write all about that in the book.
And Ellen's great too, because she was asked at one point to be on a science reality show by one of the networks that are on cable, and she said, "Well, how are you going to treat the scientists? What are they?" And they're like, "Oh, well, we'll just see how that goes." And she says, "No, thank you."
I know. I actually said on one of the reality, I said, "Well, I won't do anything. My credibility is incredibly important to me." as a scientist. So I'm not going to do anything or say anything that is going to be totally mortifying or embarrassing. They're like, beep, could not hang up fast enough.
Any other questions?
Yeah.
Yes, sir. Oh, how about right here in the front? Yes, sir.
I have a question. Large cities can send up a lot of heat.
Yes.
We live up north near New York City. And I've noticed weather patterns coming from west to east, literally about 50, 60, 70 miles west of the city begin to split. Is this something that is normal with large cities?
Yeah, that's a great question. And
Repeat the question.
Most likely. The question was, in large cities, they release a lot of heat. And is that impacting weather systems that move towards those cities? And yes, they do. There is, it's called the urban heat island effect. And when they absorb the solar radiation, they have heat, and that heat does rise up. Sometimes it tends to dry out rain or precipitation. It happened today in Washington, D.C., when there was some snow moving that way, and you could just see the snow kind of moving around Washington. There was a little hole. Even Jim Cantori said it. He's like, the hole has arrived, you know, and until the atmosphere got more saturated, then it started to snow in Washington. We used to see it, we used to call it the Potomac split in D.C. when we would do the forecasting, where storms would sometimes split. So there is, I don't know if any of you have heard of Dr. Marshall Shepard, who is at University of Georgia. He's done a lot of research on urban heat island effects and how urban heat island effects can enhance precipitation as well, because precipitation requires rising air and condensation, and sometimes you get precipitation maximums over the cities because the air is warmer and it's creating more lift and more intense rain showers and storms sometimes. Yes. Yes, sir.
You mentioned data quite often, and it's super important to understand where that comes from. Can you talk a little bit about the importance of consistent research, supporting research, and also organizations like the National Weather Service that are actually using that data?
Thank you. So the question was, we've talked a lot about data. Can we say something about the importance of data, providing data, the sources of data, and keeping them consistent and up running like the National Weather Service? So,
In 3 minutes.
in 3 minutes. So, one thing, in fact, one of the things I hope we want to leave you with is that how important science and data is to society, and it's a huge benefit to society, and that we believe we need to talk more about the absolute benefits to society that science and data provides. But it's an example, you know, like I was talking about with the Gulf Stream. We're never going to know what's happening if we're not out there collecting data and research and being consistent over time to see if there are trends. I'll let you talk about National Weather Service.
Yeah, I mean, regarding the Weather Service, there was a congressman one day on the floor that said, "Why do we need the National Weather Service when we can just watch the Weather Channel?" He said that. My comeback was, well, why do we need cows when we can go to the store and buy milk? Right? Data that all private sector companies use to make forecasts, data that the Weather Service uses to make forecasts is critical. 99%, or it's 95% of the data right now that goes into numerical weather prediction models comes from satellites. Satellites are orbiting, collecting data all the time, feeding that data into numerical weather prediction models. Then we have surface observations that are all around the world collecting data. We need that. We have ocean observing systems that are floating in the ocean, some of them diving down, Argo floats going down and up, taking profiles of the ocean. We don't have enough out there, but there's good data being collected. If that data input was stopped because we don't have the data and the collection, then the forecast, what goes in, is not going to be what comes out. Bad, worse, right? Bad forecast.
Yeah, all of the weather apps, I mean, that's part of it, is people have the private companies that are providing weather, all the weather apps. They're all based on the data from the National Weather Service. So all of those things aren't going to work either. So that's a very big issue, close to our hearts, obviously. Are there any Zoom questions?
Well, I think we only have time for maybe one or two or more questions in general, and because we have so many hands up here at the Blake Library, I think we'll finish up with some in-person questions. To our Zoom audience, I apologize that I didn't get to your questions tonight. It's one of the perks of attending in person is that you get top priority when your hands go up. So I always try to integrate some, but tonight, unfortunately, our Blake Library audience had a lot of questions, and I will wrap up with those.
Yes, sir.
You emphasize data, but in your work, a lot of scientific studies rely on study design and statistical analysis of the data resulting from the design. And you have issues such as bias, compounding, and stuff like that, and using the wrong statistical, making sure you use the right statistical methodology. How does that fit into your field of study? Is it as important in other areas, other scientific endeavors? Can you just address that?
Sure. Yeah, that's a great question. The question was how does scientific data integrity feed into it? How does the statistical biases feed into our field of weather and meteorology? It's critical. I mean, you have to. There's a location right at Dulles Airport called the National Weather Service Instrument Testing Facility, and they have all sorts of instruments up there, and they're trying to calibrate and validate. Even systems that are in the field today are being calibrated and validated by satellite observations to make sure, if you have a buoy in the ocean, you want to make sure it's collecting the right data. The satellite comes over and measures the sea surface temperature. Well, you need something in the ocean to validate that measurement. So there are lots of adjustments being made to make sure that the data is consistent. And, I'm talking about weather forecasting, but when you talk about climate records are, 30-year increments, running 30-year totals for figuring out normals and averages and things like that. There are biases in numerical weather prediction. There's no question about it. We say every model is wrong. It's just which one is less wrong, and how can we use our meteorological talents to make the best forecast. But you have to address statistical biases because if you don't, they'll run amok. And just like AI and machine learning, don't let anybody ever tell you AI can do weather forecasting without any other input. No way. They need to be based on physics-based models, and then take it out from there and try to learn from those physics-based models. But you'll never replace the physics-based models.
Let's do one more, I think, over there.
Just a simple question about personally. When were you a weatherman in D.C.?
From end of 1991 to the end of 2000.
We were in Northern Virginia. I thought we were.
Yay! Awesome. Thank you. Did you like what you saw? Okay. Thank you.
All right, folks, I know there's still a lot of unanswered questions here. Lots of hands are still floating in the audience here at the Blake, but that's all the time we have. We need to leave a few minutes for a book signing. Folks, please help me give a big thank you to Ellen and Dave.
Thank you.
And then, again, I just want to thank you for sticking around for the long question and answer session. Folks on Zoom, sorry we didn't get to your questions tonight. Hopefully we'll see all of you in a week for Dr. Aaron Adams' presentation all about the Indian River Lagoon. It's going to be a really good talk. Bye, everyone.